Welcome to homework.
In this problem, we are going to calculate the components of reaction at the bearings A and B. So we need to calculate AY, AZ and BX and BY. So let's start by writing the angular velocity as omega is equals to into minus 4I into radian per second. So from here we can write the omega dot is equals to omega dot xyz plus capital omega cross small omega. So this equation can be written as 12k plus 0 cross into minus 4I. So from here we can write the value for this omega dot as omega dot is equals to 12k into radian per second square. From here we can conclude that this omega x is equals to minus 4 radian per second, while the omega y is equals to omega z, so this is equals to 0 radian per second. From here we can write this omega dot x is equals to omega dot y is equals to 0 radian per second square, and omega dot z is equals to 12 radian per second square. Now let's write the moment of inertia corresponding to this system. So this Iz is equals to 1 divided by 12 ml square. Now by inserting values into this equation, we can write Iz is equals to 1 divided by 12 into the mass, which is equals to 15 lb divided by 32.2 feet per second square into square brackets open. Here we can write 3 into 0.5 feet whole square plus 2 feet whole square, square brackets close. So from here we can write the value for this Iz as Iz is equals to 0.18444 slug feet square. Similarly we can write Ix is equals to Iy is equals to 0 slug feet square. Now let's write the equation for the impulse and angular momentum. We can write sigma of capital M x is equals to Ix omega dot x minus into Iy minus Iz into omega y omega z. So this equation will give us that 0 is equals to 0. Similarly we can write sigma of capital M y is equals to I y omega dot y minus into Iz minus Ix into omega z omega x. Now by inserting values into this equation, we can write Bz into 1 feet minus Az into 1 feet is equals to 0. So from here we can write this Bz minus is equals to 0. Let's call it equation number 1. Similarly we can write sigma of capital Mz is equals to Iz omega dot z minus into Ix minus Iy omega x omega y. So from here we can write Ay into 1 feet minus By into 1 feet is equals to here we can write the moment of inertia, which is equals to 0.1844 slug feet square into the angular velocity, which is equals to 12, angular acceleration, which is equals to 12 radian per second square minus 0. So from here we can write the equation ay minus by is equals to 2.213 lb. We call it equation number 2. Now using the equations of motion, we can write sigma fx is equals to m into ag of x. So this will give us that bx is equals to 0. Similarly, we can write sigma of fy is equals to m into ag of y. So from here we can write ay plus by is equals to the mass, which is equals to 15 lb minus into 15 lb divided by 32.2 feet per second square, and here we can write 1 feet into the angular velocity, which is equals to angular acceleration, which is equals to 12 radian per second square. So from here we can write ay plus by is equals to 5.598 lb. We call it equation number 3. We can write the another equation of motion as a sigma of fz. So this is equals to m into ag of z. So this will give us the equation az plus bz minus 15 lb is equals to 0. So this will be our equation number 4. Now using equation number 2 and 3, we can write the value for ay as ay is equals to minus 1.69 lb and by is equals to minus 3.90 lb. While using equation number 1 and 4, we can write az is equals to bz. So this is equals to 7.5 lb. End of the question. Thank you.